So from our previous example, that was very specifically, we are now kind of going more general and defining logarithms on a general basis. So I'm going to focus on the actual definition over here. The introductory paragraph, I invite you to stop the video and read it. It's basically what we had just talked about in the previous video and also in the previous section of 2.3. And so here now our actual definition is that what I already started mentioning in the video before, that the logarithmic function to the base a is denoted by y equals logarithm to the base a of x. And so that is what I was just saying, and that is true if and only if a to the y's power is x. So it's just the other way around. So x and y basically switch places, and the base is always the same. Sometimes it's called a, sometimes b, and then x and y also can be interchangeably, of course. And so, but that is simply the definition. And then if you actually ever want a number, you always have to plug it into the calculator, or if it's nice numbers like 8 for instance, and you have a base 2, then you can say 2 to the third power equals 8, because simply 2 times 2 times 2 is 8. But other than that, so except for those few very nice numbers, the numbers are either really, really big or are all decimals. Now I would like to have two more introductions here. The first one is of the common logarithm, or the common logarithmic function. And the difference is really that's an abbreviation. So it's a general logarithm to the base 10. And so our base here is 10. And what we do with that 10, we simply ignore it. So we don't write it. So if we mean base 10, we just simply write logarithm of x. So if I write, for instance, let me give you an example here. If I write logarithm of 100, and I would like to know what that is, then I think about, well, if I have a base 10, 10 to the what power equals 100? Well, the answer to that one is 2, as you know. So therefore the answer to our logarithm is 2. The third introduction, in the last section in exponential functions, we met for the first time our number e, which is 2.78 and so on and so forth, the long infinitely infinite decimal, and so an irrational number. And that number comes, or is very useful in many scientific applications. And so the logarithm to the base e also gets a special name, and that is called the natural logarithmic function, or the natural logarithm. And it is denoted by simply writing ln. In Latin that would be logarithm naturalis, that's where that comes from. But it basically just simply means logarithm to the base e. Other than that, everything works the same way, but we have these two shortcuts because they are used very often, and they also have a historical background, especially the logarithm to the base 10. It's somewhat a little easier because we are operating in the number system that's based on 10. And the other part is they just had to make a decision, and then they wrote all these numbers when they didn't have calculators yet. They had tables and tables of logarithms where people calculated them out by finding the exponents and doing all these multiplications in order to then find the different logarithms. And so all that was done by hand, and so they settled on 10, having many of the tables for the logarithm of to the base 10. Now we just want to use that one more time, and now our official general logarithm definition as you have it up there. I want to use one more time with another example of 2 to the x equals 10. That is if and only if x equals logarithm to the base 2 of 10. And here, so we have used up there our definition. Maybe I can leave it both there. Yeah, there we go. And so I want to show you basically here one more time, repeat. We have our base for each of them is 2. That remains the same. So it's 2 for the exponential equation, and it's 2 for our logarithmic expression, our logarithmic equation. However, our input for our exponential function is x, while the input for the logarithmic function is 10. Right? So that is what we take the logarithm of. And on the other hand, the output then for our exponential expression it is 10, and for our logarithmic expression now, however, is x. So as you can see, they switch places. What it equals to is exactly the opposite number, while the bases remain the same. Now again, if you just ask, you don't have a calculator and you just ask on a test to find your logarithm or to solve for x is often the question, then you would be done. That you have done your part